Hi, and welcome to Calculus 30 with Miss Verity. Today we're going to be looking at 8.3, integration by substitution. Yesterday or the day before, we had talked about how to take the integral of something, but if there was an extra piece, say like this 2x, we would have done a lot of guessing about what the original would have had. So to help us with that, we can use u substitution. So this is sort of our piece that's kind of yucky. So we are going to let u be that piece. So when we take the derivative, we get, we're going to ignore that, du, so the derivative of u, equals 2 dx. So the derivative of 2x, and technically there's always a dx after, we just don't include it. Looking over here, we've got a dx. We are going to substitute that, so we need to isolate dx. So dividing by 2, we get 1/2 du equals dx. So rewriting what we have, e to the u, because we said 2x was u, times dx is really 1/2 du. So rearranging, 1/2 integral e to the u du. So integral of e to the u is e to the u. So 1/2 e to the u plus c. And then we just substitute back. So u originally was 2x, so 1/2 e 2x plus c. So for example 2, if dy dx equals 2x plus 3 cubed, this technically also has a dx in it. We don't know how to do sort of an inverse chain rule, but if this was just an x cubed, we could take the integral of it. So we're going to let u equal 2x plus 3. That's sort of the piece we don't like. So du equals 2 dx. And again, because we've got our dx, we are going to isolate that. So 1/2 du equals dx. Rearranging our our integral with our thing that we substituted. So u cubed, and dx is really 1/2 du. Integrate that, u cubed du. So we've got our 1/2, and the integral of u cubed is 1/4 u to the 4th plus c. We're going to simplify, so 1/2 times 1/4 is 1/8, and u again is really 2x plus 3, and that was to the power of 4 plus c. Okay, so we've got y is the integral of 2x times x squared subtract 4 squared dx. So our yucky piece is going to be whatever is in our brackets there. So we're going to let u equal x squared subtract 4, giving us du equals 2x dx. If we look at our original function, we can see 2x, well, we've got a 2x and we've got a dx. So those pieces can actually be substituted. We might actually, though, leave the 2 just because it's really only the x's and the dx's that are going to give us trouble. So 1/2 du equals x dx. That is what we're going to substitute. We can have numbers. So we're substituting the x, we're substituting the dx. So we've got 2, and we replaced this with u squared, and dx was replaced with 1/2 du. So simplifying, we've got the integral of u squared, because 2 times 1/2 is 1, du. And that's a pretty nice thing to take the integral of. 1/3 u cubed, so increase our power, divide by the new power, plus c. And substituting with our u term, which was x squared subtract 4, 1/3 x squared subtract 4 cubed plus c. And again, the nice thing with integrals is if you're maybe not confident that you got it right, we could take the derivative of this and it should result in exactly what we started with. All right, we're going to skip this one and we'll go to this one. Okay, so we've got 2 to the power of 3x plus 2 dx. We're going to let u equal the stuff in our power, so 3x plus 2. So du is equal to 3 dx. We are going to isolate our dx. 1/3 du equals dx. Rewriting what we substituted, we've got our 1/3. We're going to take the integral 2 to the power of u times du. Okay, if we remember our rules for derivatives, we know 2 to the u would give us, the derivative of that would be 2 to the u times ln 2. But we can see in our result here, we don't have an ln 2, which means that we need to have that in the original. Times our 1/3 times 2 to the u plus c. And simplify and resubstitute. So 1 over, I'm going to multiply 3 ln 2, because that's just a number, times 2 to the power of 3x plus 2 plus c. All right, example 5. Example 5 is negative 3x cubed times the root of x to the 4th subtract 1 dx. So really anything that's in brackets, that's going to be what we don't like. X to the 4th subtract 1. So du equals 4x cubed dx. We are going to isolate our dx term, and we also can see here we've got an x cubed. Oh, we've got an x cubed there. 1/4 du equals x cubed dx. So when we substitute, if you want, you could rewrite your integral. We've got negative 3x cubed times x to the 4th minus 1 to the 1/2 dx. That's what that piece was. So we are substituting out the x cubed. This is our u, and we are substituting out the dx. So negative 3, or the integral of negative 3 u to the 1/2 times 1/4 du. Simplifying, we've got negative 3/4 integral of u to the 1/2 du. So when we increase the power, 1/2 plus 2 over 2 is 3 over 2. And we are dividing by 3 over 2, so that means we are multiplying by the reciprocal. So our negative 3/4 stays. We would be multiplying by 2/3 u to the 3 over 2 plus c. When we simplify, the 2's reduce and those reduce to be 1. So all we're left with is negative 1/2. This whole fraction went away, so it's just u, which our u really was x to the 4th. Subtract 1, that is to the 3 over 2 plus c. We'll skip that one and we will do this one. I think this will be, we might do one more example. Okay, so when we think of what we might want to get rid of, we've got both a sine and a cosine, so we want to pick one of those. When we think of our letting u and what our du might be, we've got the derivative of sine is cosine, and the derivative of cosine is negative sine. I'm going to pick this as my u. So we're going to let u equal cos of 2x. So du would be negative 2 sine 2x dx. And we can see in our equation, we've got a sine 2x, so we are going to isolate that, and we've got a dx. So negative 1/2 du equals sine 2x dx. So negative 3/2, because we've got our negative 1/2 and we've got our 3. Our integral of, we eliminated this and this, because that is going to be our du. So we're left with cos of 2x, which was our u. So u du, and that's it. Integral of u is 1/2 u squared plus c. Our u was really cosine 2x, so negative 3/4 cos of 2x squared plus c, which you could also write your cos of 2x squared as cos squared 2x. That's the same thing. Pick your favorite look. They're the same, as I said. We are going to skip this one, and we will do this example. We can take the derivative of anything that's like to the negative 1. So this would be, if I rewrite it, 2x plus 4 to the negative 1. We can do a u to the negative 1. So 2x plus 4 du is then 2 dx. So 1/2 du equals dx. 1/2, our integral, we could either do u to the negative 1, or we could do 1/u du. If you remember from our derivative cheat sheet, 1/u or u to the negative 1, that is the derivative of ln x, or in our case, ln u. It's in the absolute values because it has to be a positive number, so it's just making sure it's defining as that. And last but not least, we are going to substitute our 2x plus 4 back in. There you go. Now we should hopefully have some understanding of how to take the integral using u substitution.